Good morning, children. In this class, let us start exercise 3. The exercise 3 is related to the surface area and volume of frustum. Let me take the first problem. A container open at the top is in the form of a frustum of a cone of height 24 cm and radii of its lower and upper circular ends are 8 cm and 20 cm respectively. Find the cost of milk which can completely fill the container at the rate of 21 rupees per litre. See, the container is in the shape of a frustum. The radius of the upper and lower ends are given. Let the small r is 8 cm and capital R 20 cm and the height of the frustum is given 24 cm. Right? Small r is equal to 8 cm, capital R is 20 cm and height of the frustum is 24 centimeter. You know the volume of the frustum. So what is volume of frustum? Volume of container. The container is in the shape of a frustum. So volume of the frustum is 1 by 3 pi h into r square, capital R square plus small r square plus capital R into small r. Now 1 by 3 pi, substitute 22 by 7, the h is 24 and capital R is 20 square plus small r is 8 square plus 20 into 8. 3 ones are 3 8s are 24, 22 into 8 is 176 by 7, 20 square is 464, 160. Next 176 by 7, add 400 plus 64 plus 160, that is 624. Now multiply 176 into 624, that is equal to 109,824 by 7. So you will get 1,09,824 by 7. Divide 1,09,824 by 7, you will get 15,689.142 centimeter cube. Now the volume of the container is 15,689.142 centimeter cube. Now we have to find out the cost of the milk in litre. So convert the centimeter cube into litre. You know 1 litre is equal to 1000 centimeter cube. So to convert the centimeter cube into litre, divide by 1000. So 15,689.142 by 1000. When you divide by 1000, that is converted into a litre. So 15.689 litre. Now you got the volume of the container. The volume of the container is 15.689 litre. Now find out the cost of the milk. Now cost of milk is equal to volume into rate. Volume is 15.689 litre and the rate is 21 rupees per litre. So if you multiply 15.689 into 21, that is 329.47 rupees. So the cost of the milk is 329 rupees 47 paise. Next problem. A metallic bucket open at the top of height 24 cm is in the form of the frustum of a cone. The radii of whose lower and upper circular ends are 7 cm and 14 cm respectively. find the volume of water which can completely fill the bucket and the area of the metal sheet used to make the bucket. Here the radius of the upper end and the lower end are given. Let small r is equal to 7 centimeter and capital R is equal to 14 centimeter, and the height of the bucket is given, h is equal to 24 centimeter. So next we have to find out the volume of the bucket and also the area of the metal sheet required to make the bucket. So you know volume of frustum, volume of water is equal to volume of frustum, that is 1 by 3 pi h into capital R square plus small r square plus capital R into small r. 1 by 3 pi, substitute 22 by 7 into the h is 24, capital R is 14 square plus small r is 7 square plus 14 into 7. Next 3 ones are 3 8s are 24, 22 into 8 is 176 by 7, 14 square is 196, 49 plus 14 sevens are 98. 176 by 7 into 343. Next, divide 343 by 7. It divides 49 times. 176 into 49 is 8624 centimeter cube. Now you got the volume of the water. To find the metal sheet required to make the bucket, first we have to find out the slant height of the bucket. Next, find out slant height of the bucket. Slant height L is equal to square root of h square plus capital R minus small r whole square. So h is 24 whole square plus capital R is 14, small r is 7, 14 minus 7 whole square. Next, 24 square is 576, 14 minus 7 is 7, 7 square is 49. 576 plus 49 is 625. 625. The square root of 625 is 25 centimeter. So the slant height of the frustum is 25 centimeter. Now we have to find out the metal sheet required to make the bucket. Therefore, area of metal sheet required is equal to find the area of the metal sheet required, we have to find out the curved surface area of the frustum and also the area of the circular base. So area of the metal sheet required is equal to CSA of frustum plus area of circular base. CSA of the frustum. So you know CSA of the frustum, pi into capital R plus small r into L, and the area of the circular base is pi r square. Here we can take pi common factor, r plus r into L plus r square. Substitute pi value 22 by 7. Then the capital R is 14, small r is 7, and the slant height is 25 plus 7 square. 22 by 7. 14 plus 7 is 21 into 25 plus 7 square is 49. Next 22 by 7, 21 into 25 is 525 plus 49. So 22 by 7, 525 plus 49 is 574. Divide 7 ones are 7 8s are 7 2s are. So 22 into 82. 22 into 82 is 1804 square centimeter. So the area of the metal sheet required to make the bucket is 1804 square centimeter. Next problem. A bucket is in the form of a frustum of a cone and it can hold 28.49 liters of water. If the radii of its circular ends are 28 cm and 21 cm, find the height of the bucket. Here, the radius of the two circular ends are given. One is 21 cm and 28 cm, and then the volume of the water is given 28.49 liter. You have to find the height of the bucket. Let small r equals 21 cm, capital R is equal to 28 centimeter, and the volume is equal to 28.49 liter. So here the radius are in centimeter, the volume is in liter. So convert the volume into centimeter cube. So you know the 1 liter is equal to 1000 centimeter cube. So 28.49 into 1000 centimeter cube is equal to 28,490 centimeter cube. So the volume of the water is 28,490 centimeter cube. Next, we have to find out the height of the bucket. So you know the volume of the frustum. Volume of frustum. Here frustum is nothing but bucket. Volume of bucket is equal to 1 by 3 pi h into capital R square small r square plus capital R into small r. So substitute the volume of the water 28,490 is equal to 1 by 3, 22 by 7, and h we have to find out. Right as it is, the r is 28 whole square plus small r is 21 whole square plus 28 into 21. Next, 28,490 is equal to 22 by 21 into h. 28 square is 784, 21 square is 441, 28 into 21 is 588. 28,490 is equal to 22 by 21 into h into the sum of 784 plus 441 plus 588 is equal to 1813. Next, take the cross multiplication. H is equal to 28,490 into 21 by 22 into 1813. Divide 28,490 by 22. It divides 1295 times. It divides 1295 times. Next, multiply 1295 into 21, that is 27,195 by 1813. If you divide 27,195 by 1813, that is equal to 15. It divides 15 times. So h is equal to 15 centimeter. Therefore, the height of the bucket, is 15 centimeter. Next problem. The radii of the circular ends of a bucket of height 15 centimeter are 14 centimeter and r centimeter. If the volume of bucket is 5390 centimeter cube, find the value of radius. Let h is equal to height of the bucket is 15 centimeter and capital R is equal to 14 centimeter and volume is given 5390 centimeter cube. We had to find out the radius of the lower end. You know the volume of the frustum. Volume of bucket is equal to 1 by 3 by h into capital R square plus small r square plus capital R into small r. In place of volume, substitute 5390 1 by 3 22 by 7 into h is 15, capital R is 14 square, small r we have to find out, right as it is. Next 14 r. Here we can divide 3 ones are 3 5s are. Next 5390 equals 22 into 5 is 110 by 7. 14 square is 196 r square plus 14 r. Next 5390 into 7, we can take this 110 to denominator, is equal to r square plus 14r plus 196. We can cancel the 0. 11 ones are 11 fours are 11 nines are. Next 49 into 7 is 343. Take this 196 to left hand side, minus 196 is equal to r square plus 14r. So r square plus 14r is equal to 343 minus 196 is 147. R square plus 14r minus 147 equals 0. Now factorize the equation. The product should be 147 and the difference should be 14. So the two factors are 21 and 7. So the two factors are r plus 21 into r minus 7 is equal to 0. Equate the each factor to 0. Then you will get r plus 21 is equal to 0. R minus 7 is equal to 0. So r is equal to minus 21. R is equal to plus 7. Here we are considering only the positive value. Therefore r is equal to 7 centimeter. So the radius of the lower end is 7 centimeter. Next problem. The radii of the circular ends of a solid frustum of a cone are 18 centimeter and 12 centimeter respectively, and its height is 8 centimeter. Find its total surface area. Here the radius of the smaller and the bigger ends are given. Let r is small, r is equal to 12 centimeter and capital R is equal to 18 centimeter, and the height of the frustum is given, h is equal to 8 centimeter. We have to find the surface area. To find the surface area, first we have to find out the slant height of the frustum. So L is equal to square root of h square plus capital R minus small r whole square. The height is 8 square plus 18 minus 12 whole square. So 8 square is 64. 18 minus 12 is 6. 6 square is 36. 64 plus 36 is 100. Therefore, the slant height is 10 centimeter. Now, the TSA of the frustum. Now, TSA of frustum. TSA of the frustum is pi into capital R square plus small r square plus capital R plus small r into L. So, pi R is 18 square, small r is 12 square plus capital R 18 plus 12 and the slant height is 10. Next, pi 18 square is 324 and 12 square is 144. 18 plus 12 is 30. 30 into 10 is 300. Pi, the value of the pi is 3.14. Substitute 3.14 into 324 plus 144 plus 300 is equal to 768. 768. So multiply 768 into 3.14. You will get 2411.52 centimeter cube. Centimeter square. So the total surface area of the frustum is 2411.52 square centimeter. Next question. The slant height of a frustum of a cone is 4 centimeter and the circumferences of its circular ends are 18 centimeter and 6 centimeter respectively. Find the curved surface area of the frustum. Here, the slant height of the frustum is given. Right. L is equal to 4 centimeter and the circumferences of the two circular ends are given. Let the C1 is equal to 18 centimeter and C2 is equal to 6 centimeter. We have to find out the CSA of the frustum. C1 is equal to, now C1 is equal to 18 centimeter. Thus you know the circumference. Circumference is equal to 2 pi r. 2 pi r is equal to 18. So r is equal to 18 pi 2 pi 2 9s are. So capital R is equal to 9 by pi. And C2 is equal to 6. So 2 pi small r is equal to 6. Then small r is equal to 6 by 2 pi. 2 1s are 3s are. So small r is equal to 3 by pi. Now we know the radius of the upper end and the radius of the smaller end. Next, CSA, chord surface area of the frustum. Chord surface area of the frustum. You know the curved surface area of the frustum, that is pi into capital R plus small r into L. So pi, write as it is, capital R is 9 by pi, small r is 3 by pi and the slant height is 4 centimeter. Pi, take pi common factor, pi into 1 by pi is equal to 9 plus 3 into 4. We can cancel this pi. 9 plus 3, 12 into 4, 48. 12 4s are 48 square centimeter. So, the chord surface area of the frustum is 48 square centimeter. Next question. The height of a cone is 40 centimeter. A small cone is cut off at the top by a plane parallel to the base. If the volume of the small cone is 1/64th of the volume of the given cone, at what height above the base is the section made? Here ABC is a cone. The height of the cone is given, that is 40 centimeter, and the plane DE cuts the cone ABC into two parts. The upper part is a smaller cone and the lower part is the frustum. Let the height of the smaller cone be h, and the volume of the small cone is 1/64 of the volume of the cone ABC. Now consider the triangle APE and the triangle AQC. In triangle APE and triangle AQC, angle APE is equal to angle AQC. Angle APE is equal to angle AQC is equal to 90 degree. Both are right angles. And angle PAE is equal to angle QAC, because common angles. Here that in triangle APE and the AQC, the two corresponding angles are equal. So when the two corresponding angles of the two triangles are equal, then the two triangles are said to be similar. So therefore the triangle APE is similar to triangle AQC. This rule is called as AA rule of similarity. AA rule of similarity. Then when the two triangles are similar, then ratio of their corresponding sides are equal. Therefore, now AP by AQ, AP and AQ are the corresponding sides, and PE and the QC are the corresponding sides. So AP by PQ, AP by AQ is equal to PE by QC. AP is the height of the smaller cone, we consider as small h, and AQ is the height of the whole cone, that is given 40 centimeter, and PE is the radius of the smaller cone, small r, and QC is the radius of the whole cone, capital R. So R by R, capital R by small r is equal to 40 by h. Consider this as equation 1. Then according to question, the volume of the smaller cone is 1/64 of the volume of the cone ABC. The volume of the smaller cone is 1/3 pi r square h, and the volume of the whole cone is 1/3 pi capital R square into capital H. Here we can cancel this pi by 3. Next, R square H is equal to 1/64 into capital R square. Then the height of the whole cone is 40. Next, H is equal to capital R square by small r square into 40 by 64. Next, we can write H is equal to capital R by small r whole square into 40 by 64. Capital R by small r, we can substitute 40 by H. So in place of capital R by small r, we can substitute 40 by H whole square into 40 by 64 from 1. 40 square by H square into 40 by 64. Take the cross multiplication. Then H into H square is H cube is equal to 40 square into 40. We can write 40 whole cube, and 64 we can write it as 4. 40 by 4 whole cube. 4 ones are 4 tens are. So H cube is equal to 10 cube. H is equal to 10 centimeter. So the height of the smaller cone is 10 centimeter. Now you have to find out the length of PQ. Therefore PQ is equal to AQ minus AP. AQ is 40 centimeter and AP is nothing but the height of the smaller cone, that is 10 centimeter. So 40 minus 10 is 30 centimeter. So the section is made at the height of 30 centimeter above the base. Next question. A hollow cone is cut by a plane parallel to the base and upper part is removed. If the CSA of the remainder is 15 by 16th of the CSA of the whole cone, find the ratio of the line segments into which the cone's height is divided by the plane. Here, the cone ABC is divided by the plane DE into two parts. The upper part is the smaller cone and the lower part is the frustum. The CSA of the frustum is 15 by 16th of the CSA of the cone ABC. The plane DE divides AQ into two parts, AP and PQ. You have to find out the ratio of AP and PQ. Let the radius of the smaller cone be small r and the bigger cone be capital R, and the slant height of the smaller cone be small l and bigger cone be capital L, and the height of the smaller cone be small h and the bigger cone be capital H. Now consider the triangle APE and AQC. Here angle APE is equal to angle AQC. Angle APE is equal to angle AQC equals 90 degree, and angle PAE is equal to angle QAC, common angles. So if the two corresponding angles of the two triangles are equal, then the two triangles are said to be similar. Therefore, triangle APE is similar to triangle AQC by AE rule of similarity. When the two triangles are similar, then the ratio of their corresponding sides are equal. Therefore, take the ratio of the base. Here PE by QC, PE by QC is equal to AE, the ratio of the slant height, AE by AC, and the ratio of height is AP. AP is the height of the smaller cone and AQ is the height of the bigger cone. So PE by QC is equal to AE by AC is equal to AP by AQ. PE is the radius of the smaller cone and QC is the radius of the bigger cone, and then AE is the slant height of the smaller cone, capital L by small l by capital L, and AP is the height of the smaller cone, small h by capital H. So consider this as equation 1. Now according to question, the CSA of frustum BCED is equal to 15 by 16th of the CSA of the cone ABC. Now we can write the CSA of the frustum BCED as the CSA of the cone ABC minus the CSA of the cone ADE. If you subtract the CSA of the smaller cone by the CSA of the whole cone, that gives the CSA of the frustum. Next, 16 CSA of cone ABC. Here in the RHS, 15 CSA of cone ABC is there. If it takes this 15 CSA of cone ABC to left hand side, 16 minus 15, that is 1 CSA of cone ABC, and take minus 16 CSA of cone ADE to the RHS, then you will get 1 CSA of cone ABC is equal to 16 CSA of cone ADE. 16 CSA of cone ABC minus, if you take 15 CSA of cone ABC to RHS, then it becomes minus, and take the 16 CSA of cone ADE to RHS. 16 minus 15 is equal to 1 CSA of cone ABC is equal to 16 CSA of cone ADE. Next, so the CSA of cone ADE by CSA of cone ABC is equal to 1 by 16. Next, the 1 by 16 is equal to CSA of cone ADE by CSA of cone ABC. 1 by 16. The cone ADE. ADE is the smaller cone. The CSA of the smaller cone is pi RL and ABC is the bigger cone. So the CSA of the bigger cone is pi capital R into L. We can cancel this pi. Then 1 by 16 is equal to R by capital R into small l by capital L. Now see the equation 1. From equation 1, the small r by capital R is equal to capital small l by capital L is equal to small h by capital H. So we can substitute h by small h by capital H in place of small r by capital R and in small l by capital L. So 1 by 16 is equal to, we can substitute small h by capital H into small h by capital H from 1. Then 1 by 16 is equal to h by capital H whole square. So h by capital H whole square is equal to 1 by 4 whole square. Therefore, small h by capital H is equal to 1 by 4. Then the small h is equal to capital H by 4. Now you got the height of the smaller cone. See, the small h is nothing but AP. Therefore, AP is equal to capital H by 4. Next, find out the length of the PQ. Then PQ. Then PQ is equal to, so PQ is the height of the frustum. If we subtract AQ minus AP, that gives the PQ. AQ minus AP. AQ is the height of the bigger cone, that is capital H. AP is H by 4. So 4H minus H is 3H by 4. Then take the ratio of AP and PQ. Therefore, AP by PQ is equal to, AP is H by 4 and 1 by PQ is 4 by 3H. So we can cancel this 4 and the H. Therefore, AP by PQ. AP by PQ is 1:3. 1 by 3. 1 by 3 means AP is to PQ is equal to 1:3. Therefore, the plane DE divides the height of the cone AQ into AP and PQ in the ratio of 1:3.